Okay, so I'm going to do number 10. If you are confused with what I do in number 10 because I don't have the formulas here, go back and look at number 9 because that will definitely help you. All right, so overproduction of uric acid in the body can be an indication of cell breakdown. This may be an advanced inclusion of a disease like gout, leukemia, or lymphoma. Over a period of months, an adult male patient has taken 9 blood tests for uric acid. The mean concentration was 5.39 milligrams per deciliter. I think that's what it is. Sorry. The distribution of uric acid in healthy adult males can be assumed to be normal with a population standard deviation of 1.91. That letter is the sigma, and that indicates in statistics the population standard deviation. Okay, so it wants me to find the 95% confidence interval for the mean population. So I need to find a confidence interval. Okay, first thing, what is the margin of error? Okay, I'm going to bring up my calculator again. All right, so 95%. Again, have this with you on the test. If I look at 95%, I get 1.96. So that is my critical value. So let me bring this up. So I'm going to clear this out, 1.96 times, okay, parentheses again. I'm going to do that standard deviation of 1.19, or excuse me, 91, sorry. Ooh, flipping those numbers today. Divided by, I have a sample size of 9. So I'm going to do the square root. Oops, not that one. The square root. That was the square of 9. Close that parentheses, close it again, and I get a margin of error of 1.247. To make my life easier, because it wants 2 decimal places, this is going to be 1.25. 1.25. Okay, so here we go. So 1.25, and now I need to find the lower limit. And I know my mean concentration is 5.34. So I'm going to do 5.39 minus 1.25. Hit that, and I get 4.14. Okay, and the upper limit, I'm going to do 5.39 plus 1.25. Okay, below the mean you subtract, above the mean you add. So 6.64. Okay, so it wants to know how I knew how to do that. Well, I knew my population standard deviation because here it is, highlighted in blue. My sample size was not large because I only had 9, but I did have a normal distribution because it said the distribution, can assume to be normal. So those are the 2 things that I knew about. Okay, so what does this lower and upper limit mean to me? It means that I am 95% confident that the true uric acid level will fall between 4.14 and 6.64 milligrams per deciliter. Okay, so now I just need to find the sample size when the margin of error is 1.12. Okay, so I'm going to clear this out so I don't confuse anybody. Okay, clear. Okay, first step I need to do is I need to use that 1.9. Oh, let me do this. Before that, I need to add some parentheses. I need to do 1.196, which was my critical value because I was looking at the 95% and 95% there, times, okay, I need my standard deviation, 1.91. Close that parentheses, and then divide by my margin of error, which is 1.12. Okay, and then I close my parentheses. I use a lot of parentheses to make my life easier and make the calculator work better. So I've got 3.342, but remember the last step is I've got to square it. So I get 11.172. Anytime you have a decimal, you've got to round up because I can't have 11.17. Well, I can, but it doesn't make sense for a sample size. I need a whole sample, like a whole number. So I'm going to put this as 12. And if you get confused, remember when you're doing these problems, it shows you step by step of what I did. Hope this helps.